We're going to go into a brief introduction for set notation at this time. A set is a collection of elements or members. And to symbolize a set, we use a capital letter, for example, an A, and we put the items of that set, the elements or members, inside brackets. So whatever I want to put into the set, I write inside the brackets. Now, the items inside my set can be numbers, or they could also be words. So, for example, boy or girl, or, well, let's just do number 1. A is the set of colors of the American flag. We symbolize it with a capital A, and we open up my brackets so I can write my members or elements inside. The colors of the American flag are red, white, and blue. Those are my elements, or members, because they make up the set, and there are 3 of them. So we'd say the size of that set is 3. Another example, B is the set of the first 4 positive integers. We open up our bracket. The first 4 positive integers are 1, 2, 3, and 4. So those are the members of that set. And we know that the size of that set would be 4. Now there are 3 basic operations I want to talk to you about. The first operation is called the union. The union is symbolized with a U. And the union, as you might expect, means that the 2 sets are added together. So if we look at this in a Venn diagram form, we have set A, and we have set B, and they may or may not overlap. So in this case, A is going to be 1, 3, 5, and 6, but notice that 6 also occurs in B, so it goes in the middle. And set B is 0, 2, and 4. The union means to combine them. So when I talk about the union, we're going to look at the entire space that is occupied by both A and B. So the union means combine. So to write this as a function or an operation, we would write A unite B. This means we're going to combine set A with set B. And my resultant set is going to be the combination of all the numbers that are inside both of them. So if we start from least to greatest, we'll have a 0, 1, 2, 3, 4, 5, and 6. Notice that I just went 0, 1, 2, 3, 4, 5, and then 6 shows up in both locations. Even though it shows up in both locations, we only need to write it once. So 6 would be written just once. So the combined set of A unite B would contain all of the members of both of those sets. The next one is called the intersection, and the intersection is symbolized with an upside down U. If we look at a Venn diagram for an intersection, notice that I've used the same sets. The intersection is where they are in common, so what the 2 sets share in common. You might want to think about an intersection for a street. When you have an intersection for a street, the intersection is the part right in the middle, so it's what the 2 streets share in common. So if we draw another Venn diagram for set A and set B, we have the same values we had before, 1, 3, 5. The 6 was in the middle, and then for B we had a 0, 2, and 4. For the intersection, it's where they're shared. That's going to be right here in the middle. The only part that overlaps here is that 6. So I would write A intersect B is equal to, I open up my new set, and I write down all the numbers or all the members of both of those sets that are shared or in common. In this case, there's only one number. That's a 6. So my set here is just 6. And the size of that set would be 1, because there's only one member or one element. The last operation is called the complement. And the complement is sort of like the opposite. It's a new set that includes items that are not in the original set. Now, before we do this, we have to make up a universal set. And a universal set is used with is defined by a capital U. Usually the universal set includes all numbers. In this case, we're going to limit it to just the digits 0 through 9. So that would be 0, 1, 2, all the way up to 9. And if we look at a Venn diagram of this, we have set A, which includes 1, 3, 5, and 6. And then we have the universal set outside. And the universal set includes all of these digits, as I said before. The complement means that we want the items that are not in the original set. So if we look at A, the items that are not in A are all those that are outside of it. So the numbers that are outside of it are whatever is not included in A. So those numbers must be 0, 1's already included, 2, 3 is already included, 4, 5's already included, 6 is already included, and then 7, 8, and 9. Notice that those are the digits that are still in the universal set, but they are not in set A. The way we write this for the complement, there are different ways. The way we're going to use is called prime. So we're going to write A prime, and that little tick mark is called prime, and it simply means the complement of A. So what is opposite or not inside of A? So A prime equals, we open our set, we include all those numbers not inside A, so not inside A, but that are inside U. And then we found those over here. So we open it up, 0, 2, 4, 7, 8, 9. So this set would have a size of 6. And just remember that the complement is the opposite. It's what's not included.